Okay, so let's just have two cases here. AST type is a function call. We do one thing, otherwise we keep doing what we've been doing. So a function call looks like this. Let's just say, is that an expression? I don't even know. It doesn't matter, but it's an operator. Okay, it might look something like this. Name the function we're calling. Parameter. So these are all parameters. So when we see one of these, what needs to happen is we can't resolve the function name yet, because when we try to resolve the function name, we look over the entire AST for that function that matches. We can find functions that match by name, but we haven't resolved our parameters yet, so we can't match the parameters. So in this specific case of a function call, we need to resolve all of our parameters first. Resolve our parameters, and then go back and resolve the name at that point, because then we can find an exact match. Let me plug in my tablet here. Hello? Yo. Okay, what's happening? There. Okay. Right, so we have to resolve all the parameters first, then we can match the name. So if it's a function call, wait, do our parameters first, then we can resolve the name. We can't match to a decl function, decl, without knowing our parameters. Okay, do the same thing, but we'll say if child index, if not child index, we're the first child. Continue. So, and then we keep doing what we do before. Okay, and then do we just do us? Is that really it? Child. This is me. First than us. Now do our we never resolve the function call itself. Now do the function name. Which won't, okay. this will be AST children 0. So now, if we look at this function call for print, we still don't know print. That's bad. We do know what format is, though. That's this call. So we've matched format to this 4044D572, which is right here, 4044. So here's that format, and we know it's a short string. So here we know we passed a short string, a string literal, and an integer. So we should be able to resolve this, and we don't. Why? And I think I can consolidate these two things, but I want to get it working first. So why don't we resolve? Let's do if. Let's do an if here just so I can stop on this print. So if I look at the declRef and see that its name is print, I just wanted to give me a way to break here. Oh, wait, we actually, hold on, before we do that, we broke something else. I didn't even see that. Let's just, what did we break by doing that? Platform was not declared in push size. So in push size, we call platform. Okay, that broke a dependency map. Because now it doesn't think that this relies on platform. Why? For each node of the AST. Oh, I do still need this. Because our function name might not be just a name, like in that case. In this case, our function call is not just a name, it's a member dereference, it's an operator. Right? Yeah, okay, whew, no big deal. So what happened there? Yeah, so this, before we can just do our name, actually, do I have to do that? Because that, I think, will take care of it, because it calls itself, so yeah. So, once again, let's see. Why is it not connecting up? That's what I want to know. Here we go. Does not know what print is. Yeah, let's figure out why. So did I re-enable that? I did. Let's go here and break. Nope. Okay. So the child in this case is the declRef that should be print. Okay. So we skip over that. Yep. We already know this all works. So now we go, let's go here. So we've connected up all of our children. right? So if I look at the function call, these don't need connected because it's a string and an integer, they're just literals. This, it should be format, which it is, and we connected it. So our decl node is connected to something, so that's fine. What we're trying to do now is our name, declref, which is print. We want to connect its node to a function. Right. This won't actually work because this print function does not exist. This print function is being generated. So if I go here, this print function is a function template. So see how it takes an any parameter? Because of this, the metaprogram sees this call, says, I don't know what print is. Let's see if there's a function template for it. Or if the metaprogram needs to generate one, it sees, oh, it does, it generates it. So this is the second part. What I wanted to do is, in those cases, the metaprogram should be able to, if we have a match and we generate the function, add function decl to program, we will say, this is in util add function decl. Do we return it? We do. And do we return, if function exists, I want to return that function, add function decl to program. Okay. If it already exists, I want to return the function. If it matches, return the node, otherwise return 0. Function node. If function node, we want to return the function node. Otherwise, we try to create it. Okay. So now we say here the function call that got us here, which is called function call. Its children, its first child's info expert declref decl node equals this generated function. And there we go. We now connect up. That's very good. But I noticed we didn't get a print. Why didn't we print? Oh, because I'm grepping. Yes. Okay. That's actually fantastic, because that's kind of exactly what I wanted to do tonight. And that was very simple. Where am I writing that garbage out? Print node nicely. Where am I printing all this garbage out? Post pass primary secondary. Post pass primary. I can get rid of that. Get rid of that. Where are all those prints coming from? I need to find those print node nicely. It's definitely one of these. Oh. I literally looked right at it. I didn't realize that's what that was. Okay. Great. And if we look at the tree, let's just grep for anything that we didn't connect and see what they are. That seems bad. Append string should never... Why are those not connected to anything? How is that? There should not be this many unknowns on our name resolution. I'm pretty confident about that. Okay, let's just look and see where that's happening. ConnectDeclRefs. Oh, before I do this, let me consolidate these two things. So we can say if we're a function call, well, I could consolidate these two things. It will make it look a lot less clear though. Maybe I just leave it, because now it's very clear what it's doing. Okay. All right, I'll just leave that. It's more clear that way. Okay. So let's see why we are not connecting up append string. That's not where I wanted that. It's not a function call. Oh. Wait. Hold on. Wait a minute. That is a function call. I need to see what's happening around here. Yeah, that is a function call, so hold on. Let's do what we were doing before. AST children 0. I blanked for a second. Those are absolutely still function calls. So, all right. For each child node, if it's the name, skip it. Connect the parameters. So this parameter is a unary pre who has a member ref who has two decl-refs. One is the left-hand side, which is probe, And the right-hand side is string. Right? Probe string. So let's just see where we're at. Probe string. Here. Okay. Here's where we're at. This function call. We call it with probe string. We get the address of it. So this should resolve probe to this, which is this, and it should resolve string by, it knows this thing, type is a string builder node. It knows it's a member ref, so it can go look up in string builder node for string, which is right here. It should find both of those things. So if I, it's going to do its children first. So the first thing it's going to do is look at this pre-operator and do the member ref. Okay, let's just verify. So now we're in here again. And we are in the pre. So it's going to do its children, which will now be the member ref. Yep. And now it'll do the member ref's children, which are the two declRefs. So here's the first declRef, which should be probe, which it is. Oh, but it has no children, that's fine. So now we connect us, which is the declRef itself. So does it find it? Does it find probe? It did. It found probe, which is a variable. Okay, it found probe. So now we're gonna do string, which it should again find no problem. And it did. It's a struct member. That's all working great. We bounce out, and now we're back at the member ref itself. There's nothing for it to find. There's no declRefs left, so it does it. Now we're back at the function call. Yeah, okay. So we have resolved this fully. It found probe, which means it found string, which means this whole thing. It's resolved the whole thing. Great. Now we go on to this, which it should easily find. It's right there. I'm not even going to step through this one. I'm just going to say, great. Boom. Boom. So now if I look at the function call, its second parameter, its declRef, is result, and it found it. Line 40. Line 40. Okay, that's no problem. So now we can bounce back, and we're now going to do this declRef, which is the function name. Now we're going to look for a pen string that got past a pointer to a dynamic string and another pointer to a dynamic string, or a pointer to a string builder node. Wait, what? No, a pointer to a dynamic string and a pointer to a dynamic string. Yes. Okay. So let's go in here. It's not a function call. Oh, the declRef has no children. That step always confuses me. The declRef has no children, so it didn't do anything. Oh. Oops. We still have to do this part on, although I thought I said I didn't need to, because that'll connect the children. Right, this doesn't take itself into account unless I do it here. So, okay, yeah, yeah, yeah. Does that get rid of our append strings? It does. Okay, great. So that was just a dumb thing. Now let's look at, I don't know, just pick one. ToString. How about ToString? Which we are generating. Hold on. We are generating those. We're generating those in a different way, though. Ooh. That's not from function templates. That is from just this normal. Ooh, we generate two strings. Man, okay. This one's not quite as straightforward. Because this one, we're generating these two string functions based on function, or based on struct declarations. There's no function call ever happening. Like, we might generate these for structs and you just never call them. And if you never call them, well, no. The problem is the metaprogram is generating these for all the structs in the program. But the order of operations here is, so if I call it from main, which I do technically down inside of print, but if I call like ToString on sswrap, so if I do this, right, ToString is going to get called on this, but this is a function call. When this happens, this metaprogram hasn't ran yet, so my program has no idea what ToString is yet. It doesn't know until here, but at this point I've run the metaprogram on the main program at this point. So okay, how about this? How about this? Instead of doing what I did here, where I am connecting here, how about I connect it here? Okay. If you ever generate a function decl, then we're going to say connect function call to generated decl. Okay, and what that's going to do is it's going to take the we'll just pass it the, well, this has the global parser, so it's fine. It's just going to take the function, the generated function decl. Do I have a function match? What does that take? This is kind of gross. I need I feel like I need to take all of this code here that is all of this code here that is doing this matching of a function call to a, well, this is comparing it with a template. Okay, maybe I just need to write, okay. Matching. Okay, you're given a decl. What does function match do? Decl function query. Okay, hold on. Let's do function match. We'll call this function decl match. Okay. Okay. So then, instead of function decl match, we'll also have a function call matches decl. And what this is going to do is it's going to take a function call and one of these function decls, right? Yeah, because we're going to call it from here. Okay. And we need to do basically what this thing is doing. And let's just start massaging this. So query name, we'll just call this function decl. If okay, query name, we're also going to say short string call name is the function call, children 0 info expert declref decl name. So if the call name does not equal the query name, we can early out immediately. This doesn't matter because this can't be a forward decl, so that doesn't matter. If the, we'll say call num call params is going to be this, but this is going to be the so our function call looks like this. It's an empty node that has, so the number of children minus 1 is how many parameters, or how many children it has, basically. So that still just works. So if num call params does not equal the function we're generating, then also it doesn't match. So now we compare each parameter. So for each child node, of the function call, if the first child, we just skip it. And then for each of its parameters, we for each of its parameters, strip out counting the respective depths. What is get param type? What does that do? Param node. Does this take into account pointers and stuff? Gets I think it does. So I can just say if comparing these should not be this hard. So the parameters are, they have a type and a name. The type, I think, okay, hold on. How about, okay, instead of doing to this function decl thing, because it's hard to work with, let's do it after we've actually processed the function decl. So let's do that. And then can we just say the query param type is am I even using compare index? I am. Function decl, its name is in the function decl, so its children is immediately the parameters. So we'll just say this will be child index -1, and this will be function decl children are they parameters? Yes. Yes. So let's not trim this. Let's just say get param type of this thing. Yeah, that's it. Comparator. call param type is get param type of a child. Okay, let's undo all this stuff and say if call param type does not equal query param type. That's it. I shouldn't have to do anything else because that should take care of that for me, I think. So let's really quickly write call param type function call we'll just say call name. Okay. Query param type no longer this, it's so let's make sure this is not a for decl as well. So if is for decl function decl return false. A function decl, you just subtract, it just gets rid of the body. So this is again just -1. Query call params. Okay, if num call params does not equal query call params, return false. Okay. Right, I don't have to dereference, or I don't have to get its address. Definition of function call matches decl. What? Don't tell me I already have this. Codegen? I already have this. What did I do? Shit, I already have this function. Okay, for each node of type in tree, global parser AST, if function call matches decl, if for each function call in the whole program, if that function call matches this generated function, hook them up. Break out of for each. Function call matches decl. We're gonna say this function calls children, its first child, yeah, okay. This, I feel like this is gonna explode, but it's not declared. I need to clean this up. This sucks. C++, whatever. Okay, we ran, but have we cleaned up anything? No, that's still unknown. Let's see what's happening now. Oh god, even this is getting unwieldy. What am I doing? Add function decl to program. I am not calling this. So if it already exists, we can say connect function calls to generate a decl. Wait. Do I have to do that if this function already exists, then I'm not generating anything new, which means this shouldn't probably have to happen here. But here, the new node, I don't know. Still worked. Still didn't do what we wanted it to do though. So, does this ever happen? It does. Okay. That's interesting. The generated function decl is what? Print. Oh, that is working for print, isn't it? I forgot. I didn't even check to see if that still worked. And it does. That is actually working for print. Although I feel like these pointers should match, and they don't. Did it before? That's a little concerning. Let me double check if that was the case before. Okay, don't do this. And let's go back to doing this. Um, 12. Okay, it still didn't line up, so I don't like that. What would that be matching to? Definitely matches there. What is that matching to? And why doesn't this match? Okay, well, at least I know it's not specifically this that's causing this issue. Wait, this gets it now. Doing this. Let's print this whole thing out to a file and see what's going on. Okay. Print. All right, we have this. Print. As you can see, oops. These are not the same thing. So, does this show up anywhere else? No. Does this show up anywhere else? Yes. That's format strings pointer. What? Oh, we don't even check the name here, do we? We don't check the name. So it's matching to the first thing that has, and the first thing it sees that matches parameters, and format string and print always match parameters. So early out on name mismatch. Okay. If function call children okay, I think that's what that's about. Okay. Whew. That matches now. So this toString is matching. In fact. It is. But not all of them are. Well, that's int to string, but all right, hold on. ToString. Let's include that so we're only getting 2 strings. And let's also look for unknown. So we have a few here that are just not matching. And I want to get their, I forget how you do this. Is it like this? No, how do you combine grep queries? I guess it doesn't matter. I can just include the same context for both, so I'm too not in the mood to figure out and remember how to do that. So okay. So here's one. Oh, it's when we can't resolve. Okay. It's okay. This is actually fine. We can't resolve. If we can't resolve their parameter, we can't resolve the function call. So the reason we can't resolve that parameter is because it's a pound define. So I need to decide okay, so I need to decide if I just punt entirely on where are we at now? How many do we have? Let's just see what we have. I need to punt entirely on using pound defines, or there's a couple things I can do. I can expand the pound define in... I can expand the pound define where they're at, which... Can I do that? I'm trying to think. To expand it, I would have to evaluate it, which I don't really want to do, because the whole point of a macro is that it is not evaluated. It is just a textual replacement. So I could do that in the parsing or lexing step, but I also do not want to do that. That sounds gross. Or I just punt on the whole thing. So doing that actually did work. What about using a snippet? Does that also work? So this is going to go back to not working. Right? What if I use a snippet? What happens? And before I do it, I want to think through what will happen. That snippet will get evaluated. It will see it's a function call. It'll see it's a function call. It'll get evaluated. This actually, I think, will work. No. Why? Hex was not declared. Wait. Hex was not declared. What? Hex. Oh, that didn't get expanded. Why? What are you talking about? It didn't get expanded. No. Why would that... Okay, something is very wrong there. Why would that not have gotten expanded? Snippet. Update function call if snippet. Okay. It found it. That got... Wait, what? I'm calling hex with a U64. And that should get expanded. At this point, I should not be seeing hex. That's... I'm very confused. A snippet is getting expanded. Oh boy. So, toString, this right here should be getting expanded to this is what it should be getting expanded to. So I'm not expanding them in the generated code. This function call to hex should be getting expanded to the body of the snippet, which is this function call to base. That's what should be happening, which will solve this problem. So when we generate so when we generate this, okay, this is what we're generating. We're generating in primary chunk, we generate this call, which is happening inside of decl toString for a dynamic string. Oh, wait a minute. That's what I thought. This is not, this has a toString in it. So, oh, sorry, this is the return type. It's the toString being generated for, where are we? I lost it. Here. So in the toString for string builder node, we are at some point calling hex. And this needs expanded. So if this was a function call, just like this one, I think this will work. I think. Yes. So without this, it no longer works. So what needs to happen is this call to hex needs when we generate that function, we need to expand snippets on it in relation to the metaprogram, or to the main program. So again, I don't want people to have to do that. I don't want to have to remember to do that every time. So here, we want to say snippet update snippet. Wait, that happens on the post pass though. That happens on the post pass. So why that happens on the post pass? That's why I didn't think this was going to be a problem. Post pass. Update snippet calls, parser on the AST. Update snippet calls. For each type in the tree that's a function call, update function call if snippet. Parser AST in that node. Why do I need the AST for this? I don't. This does not need the AST at all. So okay. Okay, we find all the asserts, we find that, we don't find anything we generated. We don't find anything we generated. Do we look for anything we generated? Just really quickly change this to toString gen. No. Okay, we're not even querying generated functions. Why? Why not? Okay. So we do call it on format string. What happens if... Okay, let's not do this or this. That doesn't actually matter. Because we're always calling it here. So let's... I feel like that's literally where the problem is. So I have a feeling that's literally where the entire problem is. But so let's go back to snippet calls, and okay, so now we don't see toString at all, and we're gonna say let's just not do any of this for now. Let's try just, what if I just call hex? So what if I just say like short string or dynamic string test equals hex, 256, and write output length test data test length. Correct. Because now, right, okay, no, that's fine. I just want to see if it got expanded. Oh, I think it did. I think it literally did, because I don't even see it there. Yeah, it got expanded. So that's exactly what should be happening. Anytime you call a snippet, the snippet ceases to exist. It gets replaced with a function called to whatever's in, it gets replaced with whatever's in the snippet. So that is not happening on generated functions. That is the problem. Why? Because that breaks kind of a lot of things. So like when I call add function decl to program, it adds this call to hex, and it calls this, it creates a source node, adds that to the program, which adds it, add node to program. It adds it, okay, it adds it to the primary chunk, correct. Connect function calls, okay, that's fine. And then we say, okay, so the primary chunk is this thing. We run the metaprogram on it, and then the output AST is that source node, so everything gets added to that. Great. And then we append to the AST the primary chunk. We then run a post pass on the primary chunk. That should expand. That should be expanding the snippet right there. That should be doing it. So let's see why it's not. Because that's literally it. That's where it should be happening. Let's just see why it's not. Update macro calls, connect types, ConnectDeclRefs. Update snippet calls. For each type, function call, update if snippet. Okay, let's just look at this and look at node let's just look at this. Okay, create string builder. We're looking for hex. And actually, before we do this, let's get rid of this and just go back to what I was doing and see why this isn't happening. Okay. Int to C string, and actually, let's do it this way even better. Let's say where am I? 208. Let's do this. Let's give me a way to break there instead of doing this. ToString. Okay, great. So this node should have, what are we passing it? We're passing it, oh, that's the name, ToString, and we're passing it hex, hopefully. Param, so it's not this one. It's not this one. Wait a minute. Oh, it never gets called. That never gets called. But it does. I'm calling it in here. I am very confused. Oh, wait a minute. No, I'm not. Hold on. We don't do this one yet. until we get to the post pass, or until we get to the primary chunk. Now we want to do this. Okay, I was getting confused. So now if I look at this thing's children, this should be the hex call. Ellipse arg0, which is line 24. Where are we even? That doesn't even line up. Right, that won't line up. Erg. So we're calling toString from somewhere. What is our parent? Our parent is a variable called argstring. Is this in our metaprogram? No, argstring. toString param. Here. It's in the secondary chunk. Why are we in the secondary chunk? Oh, because there was no toStrings. Okay, that's fine. There was no toStrings in. Right, okay, never mind. We're fine. Although... Wait, this is out of date. I was like, well, this doesn't make any sense. Okay. Here. This, I think, is where we're at. This function call has one parameter. toString, and I'm calling it with what? Ellipse arg0, and the parameter is a character. Const char star. So yeah, so that's this one up here. That's this one up here. So that's right here. This is the one that I'm looking at right now, which is not the one I care about. I should be able to skip this and hit another one. args1. That's this one. I still don't care about this. 40. Do those line numbers line up at all? No. They're like 4 off, which I don't know why, but okay. I should skip this and still hit another one, which I do. And this is a platform API. This is the one I want. Here. We are right here now. So I call toString. Although, wait a minute. This call to toString is a function call. That's not what I'm interested in. This is a very confusing thing. I want a call to hex is what I want. This should be hex. Yes. And we never hit that a single time. Why? Why not? Excuse you? Because we call it right here. We create a function called in primary chunk to string right here. This isn't even the right one. Platform API right here. Wait. No, that's not the one that we call. It is this one. It is the string builder because it has a pointer in it. What about arena? Yeah, arena has them too. So we generate those function calls. We generate these. And at that point, we need to resolve these in the tree. So why don't we do that? Let's look at toString. Is that after? Here we go. So right here, this needs expanded. Why is it not getting expanded? We add this function to the program. We add this whole thing, which lexes and parses it. Okay. So we add this function decl to the program, which also adds it to the generation queue. And then we run the post pass on that whole chunk. So I want to know we just never see that at all. Why? let's go back to internal, and let's go back to this primary chunk, and we will just say, let's just print out the whole chunk, because I am very confused. Okay. And we will go to toString on a memory arena. Or on a string builder node. There's the function call for hex. It's right there. Why are we not dealing with it? Because that is a function call right there. And so is that. Is it because it's nested? Could that be why? Of type. If child type is node type, then oh. I can't just stop. It might have children that are also that type. We work now. Cool. That was such a rabbit hole, but we work now. We work now, which means let's stop printing out this and post pass wow, that was insane. So that works now. So if I go back to here and let's make this a snippet call as well. Cool. What if I get rid of that? What if I get rid of that? It still works because it's just evaluating. Okay. Man. Well, that's great. That's where I wanted to get, but does this still cause a failure then? Can I just call binary now? No, that still fails. Why? What if I do test? That's fine. What if I do test? Is that? Okay, what if I do that? Function format string call of overloaded to string is ambiguous. Why? secondary chunk 27. Ellipses arg 0. It's toString that. And toString print help. There's only one. How is it ambiguous? How is that ambiguous? toString print helper. There's that. Ooh, wait a minute. Because why is it generating? Any. Unpack ellipses params. Add param. Okay. Get param type. Oh, because I defined one. That's okay. Right. So I'm returning an L value. So in this case, I guess I just always want it to be that, which means why is it generating another one with a ampersand type info. I don't care about that. Oh, that's not it. It's in it's in the toString. Right here. Two strings that are being generated are I need to see if one exists. If the only thing that differs is okay. If the only difference is one is okay, I need to strip those out of both when I check exists. Decl match. Without them included. Forget the, yeah, okay. Don't compare reference at all because Well, if the pointer depths are different, then return false. If reference depth equals 1 and not reference depth, or the other way around, all right, let's just make this symmetrical so it's easier to read. If that or that, okay. It's still ambiguous. Why? So if for each parameter, if type pointer depth reference depth. So if the child has a reference depth of 1, but the other one the reference depth of 0, or so why does that work? Does this ever happen? It happened one time. Okay. That is the one I'm looking for. So if in that case, in that case, we did match. Oops. In that case, we do match. Okay. So now we should only be generating. We should only be generating a single one of those. And it's actually, we're not generating any of them because we already have one. Cool. And this should work because it's not by value or by reference. No, that still breaks in parsing. That still breaks in parsing. But this doesn't. No, that still does. This breaks in parsing? In what world does this break in parsing? I'm writing a symbol after dynamic string. Okay. Let's figure out what this is and then call it a night, I think. Let's get rid of this. After identifier. Okay. where are we? We're in generate function templates, add function decl to program. So this is when we're adding print. Okay, we're adding print, and we're parsing the print function, right? Void print. Yeah, we're parsing. All right, what are we parsing? We are parsing the print function generated by the call to this. Okay, I think we're back to the initial thing that I said. Way back at the start of this whole thing, I think what happens now is if I go to get param type here, I think we're here. I think we're in this situation. Yes. Yeah. The function call is yes. So now we're at the point where we try to get the param type of param node, which is a function call to base, which doesn't have a node connected. So here's where we're at. We are we generate a print function that takes a snippet, and that snippet is this, right? So if I just make this, I think if I just make this base 2, yeah. So now it knows what it's looking at. But if it's a snippet, it does not, because I think, do we do those in, yes, we connect the decl refs before we do snippets. Does that matter? No, that didn't matter at all. Now we work. Okay. Okay, sure. Why not? That makes sense. So now we work. That's fantastic. This won't though, because we have to know what type we are. I don't think I can do this. I don't think I can do that. No. Although, no, because snippets have to be actual code. It has to be valid code. What language is this? This is, it is pretty much C with a little bit of C++, but I I basically started writing a C parser to do the metaprogramming, and once I had a fully working C parser, I realized I can kind of add whatever I want to it. So that kind of expanded into now, it's not really C anymore because I have some special constructs like these snippets and stuff like that. So I'm just calling it they're DB files. So this will no longer compile to C, but it started out as a C parser. So I've just added some stuff to C. So for example, one of the things I added is these very simple function templates that, so you can write a metaprogram that, so basically the way this works is whenever you compile, right, if I just compile, the first thing it does if the metaprogram is out of date is it'll compile the metaprogram, then run the metaprogram, then that spits out a bunch of code, then it compiles your main program, which is that generated code, and then runs that final outputted program. So what the metaprogram can do is just spit out a bunch of code by looking at I can just print out the tree. Here's what the metaprogram sees. Here's the tree of your whole program. So if I look for main, well, it's off the top, but anyway, here's your whole program in tree form, and this is what the metaprogram can modify and edit, and then what gets generated at the end is this one single gigantic CPP file with a bunch of line directives that say where the actual code came from. This is what gets compiled, this one single gigantic file. The editor is 4coder. That I added some customizations to give me like these custom pre-procs that it recognizes and stuff. I also have a defer keyword, so I added defer so I can be like this. So the fact that this lights up, I added some customizations to it. Yeah, this started out as me wanting to just add some metaprogramming stuff to C, and as part of that challenge, it's like, okay, what does it take to parse C code? Turns out it's not that hard, it's just really time consuming. But then once I got there, I realized I can add whatever I want to it. So, yeah. So, like, for example, now the first thing that I've done with it so far is, so I have this file just called print. So I have this print function, right? And I define this special keyword any. It can either be a single parameter, so like whatever I want, or this ellipse means it's variable. And I can pass that to other things, right? So format string is another function that just takes an any. And then I have one other special keyword called forAny that lets you loop over those. However many parameters got passed in, you call forAny, and you can access the individual parameter with this param that gets inserted into your code. If you want to define a variable that has the same type that got passed in, you can do this. So I can say like x equals, whatever. This $sign param will get replaced with whatever that param's type was. So this forAny loop on the back side, if you go look at it, it gets unrolled by the metaprogram. So if I go to format string, so this function here, this format string, this is what the ultimate metaprogram generated for me. So I just have this one forAny loop, and I passed, if you look, I passed one parameter to it. So this print should have one parameter passed to it, which means the format string should only have one parameter passed to it, which it does. Well, besides the format string, right? The format string is required. It's got one extra parameter. It generated one with the format string, one extra parameter. But you can see, I say forAny, this got expanded into this chunk here, all the way to the advance. So if I had more parameters, there would be this chunk and then another chunk that looks identical, just with a different parameter. So that's how it like expands it. But what's cool is so you have these chunk files that show you the generated code. The generated program at the end that you compile, this giant monstrosity, these line directives map back to your actual source. So error messages show up pointing to where they should in your actual source code, and error messages in the generated code show up in these chunk files, again, which just looks like normal source. So you're never having to look at this giant mess. And it compiles, like, I'm in debug mode. It compiles like, so there you go. It compiled the metaprogram. So I also have a bash script set up that looks for changes in the metaprogram, so you don't have to remember, oh, I have to recompile it. It'll do it for you. It compiled my entire metaprogram in debug mode in like a second, and I'm not doing any kind of incremental compilation. It's doing the whole thing from scratch every time. It compiles the metaprogram in a second, runs the metaprogram, and actually I can print out stats too. So it compiled the metaprogram in a second. It spent only 5 milliseconds lexing my entire source, 2 milliseconds parsing it, 162 seconds in the metaprogram actually generating code, so a total of just 170 milliseconds basically. That spat out the actual code, and then here's that giant file that's all one thing was about 5,000 lines, and it compiled it in like 0.13 seconds. So, which if we look here, if I scroll all the way down, this says 9,000 something, but that's because this line count here doesn't take into account all those line directives. It strips all those out. So, and because of all the shenanigans there, I just say, it was about 4,800 lines. Like, it's not super accurate, but it's fine. But anyway, so like this print function, what's cool is I can just be like, okay, I'm gonna make a new struct here called myStruct, and it's gonna have a pointer to a U32 in it, or let's say U64, and it's gonna have a short string in it, which is just a counted string wrapper that I have. And I will say, so all I've done is define a new struct. Let's make one. We'll say temp pointer equals, I'll just make like the address of X, and temp string equals hello world. Now I just made this new struct. I just made it up. I never have to write a print function ever again. The metaprogram does it for me. So, and it knows about structs. So since the metaprogram knows what the structs are, it can loop over the members. I can just write print %/n, or I'll say my struct is %/n. I don't have to put anything here, just a %. I just put a %sign. It figures out all the types. I can just pass it temp, and here we go. My struct is, it puts braces, here's that pointer, here's the string. And it's recursive, so if that struct had other struct members in it, you would see like, well yeah, so here's an A. I'll just put this A struct in it as well. Substruct. There you go. Here's the members of that substruct A, right? So that's like the first thing I'm really doing with the metaprogram is generating these two strings and print functions for me. So not only is it generating the print function, right, which is actually printing to the console, it's also generating, to do that, these format strings. So the format string is the thing doing all the real work there to turn it into a string. You can use format string for whatever you want, right? I can call format string, instead of print here, I can say format string instead, and this should still work. Yep. Now I can do whatever I want with that string. I have the string of that I just showed you, my struct is whatever. Well, yeah, let's just print the string, so So there you go. Here's that string. So I can do whatever I want with it. There's 2 new lines because this doesn't actually need it. I can do whatever I want with this. If I have like an in-game console, I can print that to that. If I have a text editor and I want to do a format string and show it somewhere, I can use it for that. So yeah, literally just tonight I got this part working where it couldn't resolve the type of what you pass to it, so it couldn't resolve this print because I have this wrapper called base. You give it a number and a base, and then I have a wrapper for binary. It passes the number and a 2. Hex, it passes the number and a 16. So if I say binary and then number, it'll print it out as binary for you. That wasn't working before, but it is now. So that was a lot. I just went over kind of everything, but I'm pretty excited about it. So I worked on the parser for probably, I mean, it's still ongoing, but for the most part, like 3 or 4 months of just a lot of work on it. And now the metaprogramming side is what I've been focused on since I've gotten that working. So, and also it's totally cross-platform, and I'm not really using any libraries at all. The only things I'm including are system headers. So these are the only includes on Linux are these system headers for POSIX. On Windows, it'll just be the Windows system headers, and on Mac, it'll pretty much just be POSIX as well. And I'm eventually going to use it for kind of everything else as well, for like making Windows, and I'm going to turn it into a library. So powered by all this metaprogramming though. So yeah, I'm sorry, that was a lot. Hopefully, as someone who appreciates metaprogramming, this kind of thing maybe is cool. I'm very excited about it. I did what I wanted to do tonight, so I'm about to call it. I appreciate the interest. I only just started streaming. This is like my 4th stream, and it kind of keeps me on track, so I'm probably going to try and do it more. And yeah, thanks. I appreciate it. I have some kind of big ambitions for this stuff that will get there eventually, but kind of just taking it one thing at a time. I'm going to remove this to do and then probably call it tonight. So this all got fixed tonight. Wait, did it? No. No, there were other to-dos in there that got fixed. But anyway, yeah, I appreciate the interest. And thanks for the follow. I'm definitely going to try streaming more as this starts coming together more. So if you've heard of like Handmade Hero or that whole community, that's definitely where a lot of my inspiration is drawn from. So I do like the whole do everything from scratch. The actual stream is on hiatus, but because the dude is super busy and is working on a bunch of other stuff, but the whole stream archive is up. It's basically a guy making a game engine from scratch in C, like total scratch, and he streamed like the entire process, every single line of code. So yeah, if you're interested in anything like that, game engineering or even just like low-level programming, I would definitely check it out. But yeah, I'm going to push this stuff up and call it a night. Thank you. It was awesome that you stopped by. I really like being able to explain this to people because I don't get that opportunity very often. So it's just been me staring at this for months now. So Yeah, it was originally all in this layer. Like, you create functions in C++ code that modify the tree, but then I quickly realized there's like no reason I can't extend the parser to just like embed some of that stuff with like sugar, like syntactic sugar, like this any and stuff. And it has kind of just kept ballooning, and it's getting really, really cool. I'm really having a good time. So and plus the fact that it is still at the end of the day like getting spat out as C. I get to like piggyback off of this existing C compiler stack. Like, I could at some point turn this into like an actual language probably, or use like LLVM and generate my own language, but I mean, that's a ways off. I don't have a ton of desire to do that. I'm totally fine working off of C. Yeah, I started with Emacs and still use it for all sorts of stuff. So I'm very proficient with Emacs. I used it for a really long time. I just forced myself to use it until I got proficient at it, and now I'm really proficient at it. But then it's super big and bloated. So this editor I'm using over here called 4Coder, it's a C-focused editor that is customized with C code. The guy who made it came from that handmade community that built up around that guy's stream, and you customize it by writing C code and spitting out a DLL that it loads. So that's pretty cool. And it's meant to be kind of like Emacs, but it kind of does a bunch of its own stuff too. So I think it's freeware at this point. I paid for it initially, but I think at this point you can just go get it. So if you're interested. In fact, the guy who made this, he was just streaming. He might still be streaming on Twitch right now. He's Mr. Fourth Dimension. He was just streaming earlier tonight, so yeah, I get that. I have the only Lisp I know is what it took to customize Emacs for me. All the Emacs customization is in Lisp, so I know very little of it. I've touched very little of it, just enough to get Emacs to do what I want it to do. Okay, sure. Yeah, I feel like C is considered like the scary language for sure. So, yeah, that's one. I use a lot of parentheses even in C. I'd like to be very explicit about my like scopes, but yeah, man, Lisp is. What I like about C is I feel very close to the metal, as they say. I feel like it's that's partly why it's scary, right? There's not a lot of guardrails, but that's why I feel so home in it. I feel like I can kind of like do something like this and not think too much about it. I can include some system headers and kind of everything else gets out of my way, and I can just do what I want to do. But with that comes a lot of problems for sure. Yeah, go for it. It's only 11 here where I'm at, so I'm not in a huge rush. And plus, someone's here asking me stuff. I'll absolutely sit here and talk through it. I assume by buffers, do you just mean like these these panels of text? Like just showing you your... Yeah, yep, totally. Yeah. That's something that, like, using Emacs, so my day job actually is at a cloud computing company, and I work on the operating system, like our operating system, uh, and most people there use like VS Code and stuff, but I'm still one of those people who everything's on virtual machines, so I like network in through SSH, and I totally use a terminal-based Emacs at work as well, and that's a giant code base of FreeBSD and all sorts of crazy stuff. So I'm used to Emacs at this point, where like in both Emacs and this, so I can show you here. So if I close this, if I open up my editor, this is what I'll typically do. I will go to my source directory and I will just tell it to open everything. Open all code recursive, and I actually have 2 folders for this, so I'll do it in both. Now, all my code is open. If I hit Control I, here's every single file. They're all just open as buffers. So I guess I don't really know how to explain it, but I'm pretty comfortable just knowing kind of, if it's my own code base, I'm actually fine having everything open like this. I just know where things are. At work, for example, where there's no way I can know where everything is. I never just like open everything like that. I always just open the thing I'm specifically working on, which may be like at most a dozen files, maybe. So yeah, I guess I don't know if I have any advice on getting better at this part of it, other than I can at least say for my own code base, it is a lot easier if it's code that I've written. Because I also don't really use, as you saw, I don't really use any libraries. So any code I'm looking at here is something I wrote. So I know where it is, and I know... So at work in Emacs, it never autosaves. I'm always saving myself. And actually here, I'm not autosaving here either. But you can build from forcoder. There's a key combo that you can build, and if you build, it autosaves all your files. I used to do that until I started working on this parser, and I just have way too much output when you run. Like, I didn't want all of this output to be inside my editor, so I've switched to having a separate terminal window for compiling. But back when I used to compile in the editor, it would autosave everything when you build. So, but also, unlike most people's code bases, even at work, I can't just compile all the time, but you've seen how fast this is. That my workflow here, the way my code base is set up, I'm compiling the entire project from scratch constantly. I'm doing it all the time. But that's because it's built in such a way that it's fast to do that. So that's another situation where this workflow is a little different than most people. Is for a lot of people, compiling and testing is like a big, arduous step, so you just don't do it that often. I'm doing it all the time. I'm switching over, rebuilding the entire thing, and running it just over and over and over. So, yeah. And I guess for me, if I'm focused on a problem where, like I said, I have, in my own code bases, I typically just have everything open. I just know where stuff is. But like at work, like I say, I'll have at most like a dozen files open, and I'm used enough to Emacs shortcuts and where it shows you things. I don't really get lost in terms of what I have open. I normally get lost in navigating the code, which I guess is like, it'd be the difference of like using Emacs would be like knowing how to drive a car, but not knowing the code is like not knowing the area you're in, I guess. So the part of having a bunch of buffers open and knowing what's open, that part I guess I just don't really struggle with, and I think it's just because I've done it a lot for a long time. So if you're used to having like visible tabs and seeing all of that stuff all the time, I think it would just take time. Like yeah, if you just stuck with it more, like when I first learned Emacs, I just forced myself to use it and nothing else for a whole month. And by the end of that month, I was pretty much proficient with it. So, but that first chunk of time, it was definitely like every single thing was arduous. Yeah, and I avoid that here in 4Coder because I just open every file. So now the only command I use is switch buffer in active pane, right? I can switch panes back and forth, and I can switch what the open buffer is, and that's it. With Emacs, there's really only one extra one, which is open new file in this buffer. So, which is like here would be navigate to like a different file and open in this buffer. Yeah, so like, and I typically, another thing that I do is I never have more than this side by side open at any given time, which I think just helps me compartmentalize things too. So I can totally like open more of these. Split minus and p. So like I can totally 4Coder supports this as well. I literally never do this ever. I always just have my two side by side. And I feel like that just helps me compartmentalize too, because I have a weird heuristic that I can't even really describe, where certain types of files go over on the left side and certain types of files typically go on the right side, and I'm typically always doing most of my editing on the right side. So the left is like a view into something I need to work on the right side. It's a weird, like, it happens subconsciously, I think, at this point, but you do start to build up these heuristics that I think also helps. I think, like you said, it just takes time. You just have to get yourself to do it, and the more you do it, the better you'll get at it. So, but yeah, I'm more than happy to like just talk about my workflow. Yep, yeah, exactly. I totally get now why like there are certain people who are tied to their editor, even if it's really old, and they're just super set in their ways and they don't want to change. Like people who run some version of Vim from 2001 and they don't want to change. It's because I am so quick at 4Coder and Emacs, kind of both now, that the idea of like I may have to switch to VS Code at some point at work, like just as a mandate thing, and that's going to be hard. Just at this point trying to learn a new thing. So I appreciate that though. It definitely didn't happen overnight. I've been doing this for a long time, so. Yeah, that's what I'm worried about. I have a feeling there's probably a way. I can probably find a way to manhandle it to get it to behave similarly to this, but I don't know. I've never set the time to do it. I do use it in Linux as a debugger for C, because up until recently there's been no better C debugger than Visual Studio on Windows. Although nowadays I actually use, again, this came out of the Handmade community, this editor, or this debugger called Remedy BG, which is super sick and super lightweight and awesome. It is a paid product, but it came out of the Handmade community. Unfortunately, it's only for Windows. I use this debugger on Windows, but on Linux, every single visual debugger I've ever used that's like a front end for GDB have all been pretty terrible. And once I realized how to set up VS Code to work as a debugger in Linux, it's not perfect, there's a lot of problems with it, but it's the closest I can get to using a Visual Studio debugger in Linux. So I just use normal Git, and in fact, This specific project is how do I do that? I'm just using normal git and whatever. This is I'm hosting this myself. This is on my local network. This is not even hosted on a GitHub or anything. This project I'm just hosting internally, and then I have a local backup of it as well. But this is just normal git command line stuff, and I only use like legit 3 git commands. I use add, commit, push, clone, and check out. I think that's it. Like, I am not a big like crazy git person. I use like the very bare bones necessities to have a version history. So I use status a lot, and I use log a lot. And yeah, that's pretty much it. So in fact, if I go to the parser, yeah, the initial commit of when I started working on my parser was October 13th. So it's only been like, well, we're already in May, so. But is lazy git, is that just like a UI, like a front end, or? Oh, it's a terminal UI. That's cool. That's cool. I do like terminal UIs. On Linux, my file browser is Ranger, so this is all terminal based, which I appreciate. So I like me some terminal UIs. But yeah, if you stick around and like come back to the stream, you can my workflow is pretty much identical on every platform. So luckily 4Coder works on Windows, Mac, and Linux, and the only thing I had to do was, because it uses a dynamic library for the customization, I just had to make sure I recompile that dynamic library once for Windows, once for Mac, and once for Linux so it can load it. So my editor is identical on all 3 platforms. The debugger, unfortunately, is... I finally got VS Code working this same way on Mac, I think. I'm new to the Mac stuff, so I'll have to get back to it at some point. But I use VS Code on Linux, Remedy on Windows, and I just use whatever the native compiler is pretty much for each platform. So like MSVC on Windows, GCC on Linux, and Clang on Mac. So, and it's nice again because I'm not using any libraries. I can pretty much guarantee that stuff is going to compile no matter where my stuff is. So obviously it means I have to do a lot more work, but I enjoy that stuff. So like this project, the my platform layer, like I'm literally, my print functions are literally like calling the right syscall to standard out. Like I'm not, I created my own printf basically, right, with the metaprogram. That's what this print function basically is. It's like, in my opinion, a better printf. So yeah, I may call it though. It's almost 11:30, and man, I'm so stoked I got done what I wanted to do tonight. Yeah, thanks a lot for joining and asking so many questions. I think that's awesome. That's kind of what I was hoping for, was people would be interested in what I'm doing and I guess the way I'm doing it. So yeah, I look forward to seeing you in the future if you hang out more. That's awesome. Take it easy.